Welcome to this Dairy Co-sponsored webinar, Monitoring Rumen pH. My name is Toby Mottram, Professor at the Royal Agricultural University, and I've been developing this technology for a number of years. I'm going to talk about the rumen, why we monitor it, what technology is available for monitoring pH in the rumen, how we can use the pH data, a little bit about temperature, and then I'll be summarising. We have to think of the dairy cow as a community of organisms. She's obviously a mammal like ourselves. She wants to get up in the morning, eat, loll about during the day and sleep at night. But she is also host to in the order of 20,000 different types of organisms in her rumen. And these organisms have their own timelines and their own profiles. They're bacteria, protozoa. They digest things very quickly, they multiply very quickly, and they die off very quickly. And they die off particularly when the pH has fallen too low. The microbes, and I'll call them microbes because there are at least three different species within that group: the archaea, the bacteria, and the protozoa. The rumen itself is a volume which we're not exactly sure of the size because of course it changes, but it's in the order of 150 litres and it consists of famously 4 sections. The two we're most interested in are the large ventral sac and then the smaller reticulum, which is about the size and shape of at the bottom half of a rugby ball or an American football. And so a rumen bolus will sit in there with other pieces of debris that the cow has ingested, stones, nails, bits of metal, and all the other things that we give to cows that stay in the rumen. Magnets, for example, are designed to go down there. So that's where the bolus sits, down in the rumen reticulum. But in a space that size, with a number of different organisms, and there will be more at the top and different organisms from top to bottom, and we can see what the effect of these is here with this cross section through the rumen. At the very top you can see there's a gas space which is mostly full of CO2 and methane. Then there's a more fibrous material, and then there's as it gets progressively lower and lower, this is a section through the main ventral sac. If this went down to the reticulum, which would be a bit further forward along the spine, you would see that there's quite a lot of particulate material, but also that larger stones and debris will have ended up there. And you'll also find in the reticulum it's a more liquid space because it's where the saliva and water that the cow drinks arrives first. So each one of those sections of the rumen has a different pH at any particular time, and this is why monitoring the rumen is a non-trivial job. So let's look at the variation within the rumen. At the very top of the rumen you will get the gas phase, and that's where you'll get the lowest pH. In the middle is where traditionally measurements have been taken through in the ventral sac, as we call it. And if you take that as the reference point, the reticulum will have a pH 0.25 units higher than that, meaning it's less acidic. Now the first people I can find a graph from to map the pH through the day was a pair of researchers, Johnson and Sutton, at the National Institute for Research in Dairying back in the 1960s. And they pioneered a technique which has been used ever since, which is to have a fistula in the side of the cow with some electronics going and trailing the pH sensor inside. Now, of course, in those days they didn't have the transistorization or radios that we have now, but our profiles are very much the same. And as you can see, the pH varies from about 6 down to about 5, and that's consistent with what we would expect in the ventral sac even today, although in my view that is a little on the low side, but we'll come on to the reason as to why that might be in a minute. pH, for those of you who've forgotten the science you learnt at school, it means the power of hydrogen, the actual measurement of hydrogen ions with a little sensing system. And it's a measure of the chemical activity, if you like. So the lower the pH, the more acid something is, the higher the pH, the more alkaline. it is. So that was what Johnson and Sutton did in 1968, and you can see the same pattern repeat itself here. This is some recent data that we've collected, looking at a group of cows over a period of 12 days. Now the profile shows a rise most nights, it climbs up, then about 6 o'clock in the morning it drops down again, and then it bounces along, begins to rise again in the evening. Now that period when it's rising is when the cow is sleeping, or she's not eating. Maybe that she wants to eat but she can't for various reasons to do with management. As soon as she gets a big feed in the morning, the rumen bacteria start being very active. They produce lots of hydrogen ions, and the pH falls. Now we've got various techniques for measuring the pH in the rumen. Rumenocentesis is the posh name for what the vets do, where they stab the cow with a huge needle, they've stuck the needle into the side of the cow, they draw out a sample, they then try and do a pH analysis on the spot. Now there's some serious problems with this. First of all, they don't know where within that space, and we've talked about it being 150 litres, that they've actually managed to get their needle in. They're obviously doing damage to the cow. But also, more importantly, when they pull the sample out, the gas pressures change because we've moved from being in an anaerobic space to an aerobic space, and that will mean that the pH is changing very rapidly and will almost certainly be dropping. So therefore, unless they're very slick and very quick, they're going to get an erroneously low pH reading from their rumenocentesis. Another approach has also been done, which is to shove a tube down the cow's throat, and that needs to be about 1.6 metres long, and to suck some rumen liquor out and then do the analysis. Now there's several things wrong there. First of all, you're going to pick up a lot of saliva. Secondly, you don't actually know whether the tube has gone down into the reticulum or it's gone up into the top, and given that the profile may be anything up to 0.4 pH units different from top to bottom, you may not be measuring anything realistic. Now in the past 10 years, and this is the very first one I did, and I think we were the first, we've been developing technologies where we have a wireless system which will measure the pH inside the cow, inside a normal cow, not a fistulated cow. So what's a rumen bolus? There's been several on the market, and I'm not going to go into the details as to which are which, because this is not an easy technology to make work. So when you build a bolus, you've got several issues. First of all, you've got to get a good sensor that will last. pH sensors need calibrating every time they're used in laboratory conditions. And it's been a challenge to develop sensors which will last for several weeks or months. In that original Johnson and Sutton paper, they were taking the rumen pH meter out and cleaning it up every 2 days. Now clearly that doesn't work with the non-fistulated cows. So there's two main sensor possibilities. One is what's called an ISFET sensor. That has that is a plastic membrane and will measure quite accurately, but unfortunately the rumen is not a nice place for a piece of plastic. The alternative is to use a tried and tested sensor, which is unfortunately quite large with a glass bulb. They tend to be the most stable, but obviously you have to protect that glass bulb. And I can show you what the effect of this is over a number of years. That's my original one, and you can see the glass bulb in there, quite open, not particularly well protected, with a weight at the other end. And inside there is the wireless. Now, after a little while, we developed a different bolus, and it had nice large holes that the rumen liquor could flow to. And this is the bolus here. You can see the large holes there, and inside is where the glass bulb would have been. This worked okay, but what happened was that the cow is full of stones and bits and pieces, and the stones would force their way against the sensor and break it and cause the pH measurement to be incorrect. So we came up with a different method where we have lots of small holes, and we make sure that the sensor isn't isn't directly accessible by stones, so that any stones get forced past it rather than onto it. So all engineers who try and develop boluses have this problem with managing their sensors. The next problem we had to overcome is location control. There was a New Zealand bolus which was designed to float around, but the danger of that is that it would end up going into the abomasum, the third compartment of the rumen. And they developed a set of wings on their bolus, so it was too big to go through there, and they made it light, with the aim being to float it up in that chamber where most of the activity is. I'm not sure how well that worked, but the alternative is to make your bolus heavy. So this weighs about 200 grams and has a specific gravity of about 2, and that means that it's as heavy as a stone and goes to the bottom of the reticulum. The next problem we have is wireless transmissions from within a cow. Unfortunately, cow tissue and the liquid in the rumen absorbs radio signals at many of the frequencies that we would have available, for example in a mobile phone. They won't work. So we have to use ones where the cow does not absorb too much of it, and we're also limited by the legalities of wireless, and so there are two bands that boluses operate in: 433 megahertz and 902 megahertz. Either of those are free to use anywhere in the world, and so all the boluses that are on the market operate within those two bands. But the limitation there is also to do with the length and size of the antenna, so that there is a minimum size the boluses can get if they're able to transmit. It's actually not the length of the antenna, which is only a quarter of the wavelength of the radio signal, but it's the ground plane. It has to have something to be operating against. So like any building, it needs foundations, and so you do need a certain mass in there. One of the benefits of modern technology is that bolus was that size because of the wireless chip. These are smaller now because the wireless chips are smaller, but there's a limit to how much smaller they can go. The other area where we have problems is that, of course, we can't take the bolus out, so we can't change batteries. So nowadays, with good batteries, we can get some extended life, maybe up to as much as 2 years inside the cow, but that sometimes means that you have to restrict the radio. The radio takes a lot of power to operate, and so most boluses have a limitation on the number of hours per day that you can operate. Now, in very simple terms, you can map rumen pH against milk yield. The more starch and concentrates you give your cow, the higher your milk yields, but the lower your pHs go, which is fine, but if you push the pH too low, the bacteria that do the digestion will die and the cow will get acidosis. Now, subacute rumen, this is not the acidosis necessarily that a vet would be called to. This is the acidosis that we can't see, where the cow's rumen is routinely quite acidic, where the bacteria don't perform to their maximum, and also the cow's main ventral sac can develop ulcerations due to the very low pH, the very acidic nature. The Canadians developed a technique based on rumenocentesis, where if they took a sample and it was below 5.5 pH about 2 hours after a major feed, then they would diagnose those cows as having subacute rumen acidosis. But that's only one measure, and as you've seen, there's a big variation day by day. There's also a big variation wherever you take your sample. I mean, you can't always find the right spot, there's ribs in the way and so forth. Another methodology, and I think this was based on using a tubing system, was looking at the number of hours the cow spent below 5.5 pH. And that 5.5 was 5.5 in the ventral sac, the higher up. If we go down into the reticulum, the pH is always about 0.25 pH lower, and so therefore you can use a different threshold. But with the continuous availability of data, we think that you can have an acidosis index which runs on a scale of 1 to 10, or 0 to 10 I should say, and that when it's above 5 you're beginning to drift into an acidosis area. You can make up that index by looking at the flatness of the daily feeding curve, and we'll come on to that in a minute, the mean pH per day, just the average value through the day, also the number of hours of the reticulum pH being below 5.8, and also, quite importantly, is the slope of the pH drop. So after a cow feeds, if you've got a very starchy feed, it will drop catastrophically fast. But the main method, of course, is still the clinical judgment of your veterinarian or as a farmer. So we've been putting boluses into cows now for some time, and this is some data from a very high yielding herd. I think the herd average is in the order of 50 litres per day. And the pH pattern is exactly as Johnson and Sutton picked up. The cows have got high pH at night, that's about 6.4 pH, and then it's dropping down just below that 5.8 threshold fairly frequently. Now that was slightly alarming for the nutritionist, because at that level that means those cows are drifting into acidosis. The cows have got a nice regular feeding pattern, but they're not eating at night as well. If you look, they're actually they're tending to have a very high rise in pH. Now, the same cows a few days later, or one of the cows in that group, we took the values again, and as you can see, we've now gone so that virtually, apart from just at the early stage there, she's one day just dips just briefly below 5.8 pH, and then has a nice rest. But you can see later on that during that week she started to eat at night, so you can see that the pH through the night is relatively stable. And we've also reduced the range, so that would be seen as a good result from an intervention by changing the feed as a result of having automatic rumen pH data. Now, one of the main benefits of pH monitoring is that you're detecting things before milk yield changes. Milk is, of course, what you're interested in, although also the cow fertility will be affected by continuous low pH. So you can see that this group of cows was 80 days after calving, and of course there's a slow decline in milk yield, but you can see that sometimes that pH is drifting routinely below 5.8, other times it's above it, but there's no real instant change to milk yield. The benefit of monitoring pH is that you're detecting problems with the diet before the cows get ill. Now, looking at another farm, this is a farm in the West Country, and you can see that the cows in a group will tend to track each other quite closely, because one of the issues relating to wireless pH is that the boluses are not cheap. They will retail anything over £400 up to I think some of them are a lot more than that. So you're not wanting to put one of those in every cow. So we have to decide how many. We reckon about one cow in 30, and certainly 3 in any group. And you can see in this group the cows have tracked each other pretty well. There's some cow-to-cow differences, but not huge. But if we look at another group of cows, where we've actually got a huge range, and we've got some cows where the pHs are very high, up to 7, and other cows are way down below 6. So in that instance, I think you'd probably want to add more boluses, because that cow in the pink line is probably not performing in the same way as the others. She's maybe getting more feed, she's getting more time at the trough. Now, one of the major benefits of the pH monitoring is you can look at how the cows are feeding through the day. You want to avoid a very steep pattern. And here's a herd where they were on a robotic milking system with TMR, and you can see that the pH, and that red line is the average through all the blue daily lines. That means that she's not doing much anything between 6 and 6.4. She's never really going out of that zone. She hasn't got huge high peaks. She hasn't got very deep low troughs. So what we can see there is that cow is eating regularly and a little and often, which is the ideal way of feeding a cow. And being able to pick up that flat profile is a very big benefit. Some of the worst daily feeding profiles we've seen have been on cows at grass, where they come in from grass which they haven't been eating much of, and they've got a feed of concentrates, or they've been standing under the hedge and not eating at all. And so you can actually use that feeding profile to identify management issues. So, for example, here's one that we averaged over a cow over about 6 months. and in both the cows in that particular group had a similar profile. And what you can see here is that cow, the pH is rising at night, and then she wakes up round about 6 o'clock and she goes off to the TMR to start eating. But then the herdsman comes and takes her away for 2 hours, so instead of the pH dropping, as you would expect, it starts going back up again. Now, that obviously is a management issue, is to decide what you're going to do. You may feel that that's a compromise you'll accept, but you could maybe make feed available during in the collecting yard, or you could change the way in which you bring groups of cows at it. And so rather than have the cow away from feed for 2 hours when she wants to eat, you might change that. The other thing we can do is look at long-term trends. So rather than look at our daily profile with all its seesaw effects, we just take a mean of all those and we can look at effects over a long period of time. So here's some data from a cow last year. She calved in May. The farmer believed that they were suffering from acidosis, so cut her feed back in late June. You can see the pHs rose. This is the average pH. And then we got that corrected and the pH began to come down to a level and the milk yield was picking up. But then later on in the summer, the eye came off the ball, if you like, and the pHs were dropping down, well down into a zone where they could be quite dangerous. So this is the benefit of having that monitor in there for months at a time. Another feature that we've built into our bolus, and some boluses don't use this technique, but we use it to measure temperature. And our bolus only works when it's above 30 degrees Celsius, but that's why we put it in there. But we also found that we could detect when the cow is drinking. So what you can see here is a normal cow body temperature around about 39.5. The rumen's a little bit warmer than the rest of the cow because of the bacterial activity. And then every time she takes a drink, she drops the temperature of the reticulum down, and you can count the number of times per day that she's drinking. This is a very good way of detecting whether the cows have got enough water at the right times of day. We went to one farm, we found that there were some 6 or 7 hours a day when the cows could not get a drink at all, simply by looking at these curves. Now that wasn't clear to the herdsman because he hadn't thought about the way the gates were set up when someone was mucking out. So we believe that setting up a dashboard, rather than having thousands of graphs, we've combined all these data into a single acidosis index, which gives you a single number or colour on a profile of the cow. But you can always dig deeper down into the data, and the nutritionists and the vets particularly like looking deeper into the data. So let's summarise. We've moved a long way in the past 10 years. Rumen pH monitoring is routinely available. You can buy boluses, you can work with your nutritionist to analyse the data. And the main things you can do are you can manage feeding better. And you can manage feeding before the cow's milk yields are declining, and probably weeks in advance of major changes in, say, fertility. You can manage micronutrients so that you could, if someone is saying they've got some rumen modifier which will raise your pH or change your pH in a beneficial way, then you can test that and you can see the results of changing the micronutrients. My view is actually the management problem issue is one of the greatest ones. We've found in the past that we can detect changes when a different person was driving the feeder wagon and wasn't putting the right amount in. We found weekend issues. You can detect when the cows are not getting the right feed at the weekend. We've shown, as you've seen, that we can detect water failing to be available for the cows, and, for example, that issue of taking the cows away from eating when they want to be eating. And things like cleanliness of water troughs, for example, could well be a factor in some of these issues. So what will tend to happen is that you will reduce your emergency veterinary costs because you'll have fewer incidents caused by subacute rumen acidosis. So overall, the aim, as it always has been, is to improve the herd health and fertility, maybe not necessarily the individual cow with a bolus, and this is one issue we keep reiterating. When you're picking those cows to put a bolus in, it should be an average cow, one you don't mention, not your favourite cow or a sick cow. It should be one that reflects the whole group, and the aim there being to improve the herd health and fertility. So that's the end of this webinar, and I'll be pleased to take questions.
Hi Toby, thank you for joining us. You can hear us okay? Can hear you loud and clear.
Excellent. One or two questions that have come in. The first one is, you mentioned about, well, I think the question is Eamon asked, did you mention about putting them in your early lactation cows? Is there any benefit of using them in the rest of the herd?
Well, the bolus, the chief risk period for acidosis problems and nutritional problems is the first half of lactation. So it's, I think we'd like to put them into cows just before calving so we can manage the transition diet, and then you've got your 150 days, which takes you well on into mid-lactation. The cows should be pregnant then, and we find that the cow's risk of low pHs on the same diet drops away. We're currently working to work out what is the period, because it may be that we don't need to monitor even as long as 5 months, but that's what we have available, and if we can, we'll make the boluses last longer.
Okay, and in terms of the economic benefit to the farmer, what would be the main driver?
Every farm is different. Let's get that clear. Some farmers would want to say, okay, my pHs are too low, I want to get away from this danger zone, and that's what's happened this summer. We progressively removed cost out of the ration. The pHs came up above 5.8. The milk yield never shifted. So in other words, the cows were being fed, not wrongly, but just at small balances of nutrients. So that farmer saved about 75 pence a day per cow in feed, and the cost to him of the bolus was about 15 pence a day. So 60 pence a day times 350 cows, that's a very good payback. But in other herds, it might well be that they think, oh, the pHs are a bit high, we could get a bit more milk out of these cows. Certainly we've now got herds there where the pH is up around 6.4, cycling nicely, giving 11,000 litres. Yeah, maybe we could get another 1,000 litres out of these cows and still not be in the danger zone. Whereas other farmers use them to find out they've got a problem in the silage. They thought it was acidosis, turns out it was a silage problem. So every farmer is different, and because as we all know with dairy cows, it's not like pigs and poultry. We're growing half the crop, half the animal's food in a very variable climate, can be very high energy. There should be some decent silage, for example, this year, whereas 2012, terrible silage. Balancing it up is always the problem.
Okay, thanks, Toby. And in terms of the negative or the maybe potential downside of using them, do cows lose them often, and how do you deal with that? Is it easy to retrieve them?
No, once the bolus goes down a cow's throat, it never comes out. I know there are boluses that have been shown to come out. We've never found one that's definitely come out. I mean, it's always possible for anyone who's bowled a cow will know if she coughs at the wrong moment, you will get it back. But we've never had that. But our bolus is heavy, goes to the reticulum and stays there. But that bolus will stay there with all the other stuff that we put down in cows' rumens, and it'll stay there until she's slaughtered. We did actually try to develop a recovery system, but the risks of the damage to the cow were so great. It's just better to have a bolus in another cow to monitor the herd.
Okay, thanks, Toby. We're running a bit low on questions here. Is there any particular questions that farmers ask you when they're thinking about implementing this or using these boluses in their herds?
Well, we tend to work through the nutritionists and the vets, and the questions, obviously, there's what's the commercial benefit? Well, suck it and see. We started off with one farm and then 10 farms, and I have to say that very few farmers have said, oh, I don't want them anymore. They then begin to use them more tactically rather than have something in all the cow, in the cows all the time. They just say, well, let's do it when we change silage. Let's put a couple new ones into a new feed system that we're trying out. You don't have to buy boluses continuously. You can use them tactically.
Okay, another question that's come through, Toby, is how do you know that the bolus is indeed in the reticulum? How can you monitor that it hasn't floated or moved?
Well, we have in the past, that was always our worry, are we putting it in the right place? And what we did in the past was take a cow out into a field on a halter and pad around with a metal detector, and you can definitely tell that it's in the reticulum. But there's actually an even more practical way. If the bolus goes into the ventral sac, and our fistulated cow customers, our research customers, that's how they put them in, we can't get any radio signal out of the ventral sac because the bolus is so buried in all the chewed up material, and after about an hour and a half of being put in through the fistula in the side of the cow, the bolus pops down into the reticulum, the pH goes to the higher level, it's a slightly higher pH in the reticulum, and then you know that's where it is. You would tend to know it just because you can get a decent radio signal out of it. We've got a little handset, and we walk around the cow and we can measure the signal. If it's in the reticulum, you get quite a good signal. If it's somewhere else, you can't hear it at all.
Okay, and is there a critical number of boluses that you need to ensure that you get meaningful data off the herd?
That's the $64,000 question, and of course eCow would like to sell as many boluses as possible, but we're still working towards what the optimum number is. We say about 4% is about right. One in 30 cows, 1 in 25 cows. Occasionally boluses will fail. We're continually increasing the quality of production so that doesn't happen very often, and that we're constantly fault finding. So there's occasionally you will get dropouts. So you need at least 3 really in any particular group, because you can draw a line through. You can draw a line through 3 points. You can't really draw it through 2 points realistically. So we'd say 3 per group. But if you've got 150 cows in the group, you've still only got 3 boluses in there.
And how long has this data been available, for example, overseas, such in the States, and how effective have the results been? Have they been using it much over there, and have you got much to report?
This is a technology that we invented in this country. The Americans have barely caught up with us. We are getting inquiries from the US. We have 2 customers, one in Canada, one in the US, who are feed customers. We've got a competitor in Austria. There's been quite a lot of work in Central Europe with the Austrian boluses. There was a company in New Zealand, but they appear to have got into trouble, and they haven't seen them selling any. No, this is, what you're getting now, the data that we've got on our website, that is the world's leading edge on rumen pH monitoring, and we intend to stay out in front. And we're looking to the farming community to use these boluses to up our game and constantly improve our herds over everybody else.
Okay, and what is the efficacy of the various buffer products available in the market? Toby, would you like to comment on that, or?
Well, when we've sold boluses to scientists, they do sometimes give us the data and they tell us what they've done to the cows in their experiments. But in the farm situation, we have some metadata, but we haven't been doing trials where we've been comparing one buffer against another. I think that's really next season's campaign, and obviously a farmer who's got some boluses in can say, well, I'm going to try that and let's see what happens, and then a week later try a different product and see if it happens. But we sell boluses. At the moment, we're not trying to sell anybody's buffer products. We're independent. It's just data we supply.
Have you looked at any differences between sward types, such as high sugar or low NDS? Again,
you're going beyond my capabilities there, but what we do know is that the biggest benefit we saw last year with this summer with the trial that Mole Valley Farmers sponsored was in the grazing herds. You could tell whether the grass was a new lay or whether it was an old pasture, simply because the pH doesn't dip as much when the cows are turned into the field. And there was one herd where the nutritionist said to the farmer, why don't you try moving the fence in the morning, because your cows are not getting a dip in pH in the evening. In other words, they're not eating the evening grass. And the farmer changed it and immediately got a lift in his milk yield. So yes, it will be a great tool for monitoring grazing. So I'd say that but we haven't got data that we'd write up in a scientific paper.
Okay. And Toby, you mentioned that the boluses cost approximately £400 each, but what other bits of electronic kit do you need in addition to the boluses, and how much does that cost?
Well, all the information, I mean, I'm not here to sell boluses, I'm here as a professor at Royal Ag University, so the prices are on the eCow website, but you do need a radio attachment to a mobile phone, and preferably include the mobile phone in that package. Not all mobile phones support the radio systems that we use. So we use a Samsung S2 Galaxy, and we're moving on to the S4 because they do support what they call the on-the-go USB port. So the phone itself costs £400 or so, but the whole handset all integrated together, I think it's £750.
If the bolus is in the reticulum, is this going to be the same pH status as the rumen?
No, there's a difference and an offset of 0.25 pH. In the previous science, there's always been measured in the ventral sac, which is the main large part of the rumen. And it's always a little bit lower than the reticulum and slightly less dynamic. But we apply, so rather than using 5.5 as the threshold for acidosis, we use 5.75. But that's perfectly acceptable. But to be quite honest, it's actually the dynamic behavior rather than the absolute values. What's it doing? How many push-ups of feed are you giving the cows a day? Are you feeding the cows at a time they'd rather be, are you milking the cows at a time they'd rather be eating? Are you moving the fence the right time of day? Those are the sorts of questions that this answers rather than the absolute values.
We have one question in regards to a block calved herd of, say, 300 cows. Is 4% a realistic number of cows to put boluses in that type of situation?
Well, I don't see why not, because in a block calving herd, all your action is going to be in the early period. It's all going to be happening very quickly. It depends really on the size of groups you've got. If you've got 301 group, I still think 4%, what's that, 12 boluses? That would, is that right? Yeah, 4%. So you've got, you've got 4 boluses per 100, so you've got 12 boluses. You might actually find that's rather too many. You might be able to do away with them, but it depends on the grouping. But it would give you an awful lot of data, and of course in a block calving situation you've got to get it right. There's no way back 12 weeks on that you've got the feeding wrong. Next year is a long way off to pick your milk yields up.
And when would you bolus the cows, Toby? Would you do it pre-calving or at dry off? And would the number of cows you bolus differ depending on the management system, whether it's block or all year round calving?
That's a good question, and I haven't really got an answer to it. I'm currently putting some boluses into cows just before calving, which of course is always very difficult to predict, because what we want to know is that can we stop this huge crash in pH just after calving when the cows go onto the main ration, and should we be experimenting with a sort of a week-long buffering diet just to get the cow used to being milked and to the actual extra nutrient loading that she needs. But most people find that they don't want to take the risk on a cow that they bowl having problems at calving, so they'll wait until about a week past calving when the cow's settling down into her new ration. So take your pick really, and even several weeks into lactation, you're still going to get a good view as to what the whole herd is doing just by putting some boluses into 2 or 3 cows.
In terms of the boluses, how accurate do you get pH readings for, and over what time frame? So I guess the question is probably linked to, does the quality of the data decline over time? Well,
the short answer is yes, but our bolus gives you accurate data right through for 5 months, and we know that from you only have to look at that curve I put up about long-term monitoring. There you go. We put the boluses in May. There in October we were picking up low pHs. Now, the reason I can say that with confidence is the normal way a bolus fails, or a pH sensor fails, is that the reference electrode becomes contaminated, and effectively the gap between what you're measuring and the sort of ground zero, the reference electrode, goes to zero, and that means that the bolus drifts high. So what you'll see in a bolus over time is it'll go higher and higher when it starts to fail. So that is a potential problem. But what we do in our bolus is that we give you the raw data, and that's the analysis comes out. There's no software fiddling with it. The Austrian bolus has what they call drift correction, which means it's actually fiddling with the data, and you can actually, humans are very good eyeballing data and saying, oh, that doesn't look right, we should be getting a daily profile, and that's just a flat line. So we don't do that. We'd say you can detect when the bolus is failing afterwards.
And Toby, can you reuse the boluses from slaughtered animals?
Oh yes, indeed. When I designed the bolus, it was for people doing experiments in fistulated cows. So they would put the bolus into a cow, do an experiment for a fortnight, take them out, rinse them off, and store them, and then do another experiment a few months later. The problem for the bolus inside the cow continuously is the reference electrode gets poisoned. So yes, if you whip the bolus out, and you know, we'd be very interested in doing some studies in steers going in the last phase where they're getting a lot of concentrates, and then recovering the boluses and restoring them. But yes, you could probably use the bolus 2 or 3 times that way.
I have a question here that there was some data that showed the cows not eating at night. After the diet was changed, the cows started eating more at night. What was it that had changed on that system?
I'm not too sure. You'd have to ask the nutritionist involved and what magic change he made. I think it was one of the micronutrients. It wasn't one of the major constituents of the diet. I think it was just to do with some small change. As I say, these changes don't have to be very big to have quite a big change in the appetite.
And you talked about an acidosis index. Could you just expand a little bit more on what that is?
Well, we tried to put together an index which combined time below the threshold, the depth of drop after feeding. So in other words, if they had a very digestible feed, the pH will drop like a stone. What's the daily range? What are the number of feeds per day, and how many drinks per day is the cow taking? So we combined those into an acidosis index. And what we really need to know is how heavily we should weight any one of those, or is there something else we could add into the index itself? I think we're still going a long way. We've still got a long way to go before we have that acidosis index nailed down as the right way to go. So what I wanted to just give the farmer and the nutritionist a sort of general indication, you know, just a color button on the cow, but they all wanted to dive into the data because it's telling you so much about what's going on through the day, things you don't know about. You know, the old saying, the cow gets 3 diets, you know, the one you write down on paper, the one you put in front of her, and the one she actually eats. What the rumen bolus is doing is measuring the diet she eats.
Okay, and has there been any published work on this acidosis index that you've...
Well, I gave a paper at the EU PLF meeting in Leuven, which is in the book of proceedings there, and I said that this is still a work in progress. So you're getting it from the horse's mouth, basically. I've actually changed my mind about acidosis. I'm no longer sure that acidosis is one simple thing that we can call acidosis. I think it's a series of management interventions that will get the pHs into the right range and keep them there.
Could you just explain a little bit about how easy or user-friendly it is to transfer this data?
Well, the farmer doesn't have to, or the nutritionist doesn't have to do anything. Basically, that's one of the reasons we went over to the mobile phone. It's got all this wonderful internet connectivity, and the data is being tried to be sent back to our server for processing as soon as possible. Having said that, as a lot of farms don't have good internet connections by wireless or telephone, we now supply software which allows the nutritionist to look at the numbers immediately on a farm computer or a laptop and make some immediate decisions, and then the data will then transfer up to us. So to get the data out of the cow, it's a single button push on the handset, and when all the cows have been done, that data is then pinged off to the eCow server without you having to do anything.
Okay, excellent. So I think that probably takes us to the end of our questioning for tonight. Any of the questions that we haven't got to, even though I think we've answered them all, we will get back to you via email. Toby, I would really like to thank you for taking the time to do this webinar for us and for answering all of the questions.